Hey everybody, welcome back. This is part of the summer program that I'm wanting to put together. And I thought I would start with one of my favorite, easiest topics to discuss, and that is nursing math or dosage calculations. Everything in this quick lecture is very rudimentary. It's very basic. It's very foundational. A lot of conversion, a lot of really truly basic dosage calc. So let's just jump right in. Won't waste any of your time. Let's just kind of get to it. So first things first. Because you're doing a dosage calc, that means you're doing some kind of medication administration. So with pharmacology, you have to know your 6 rights. I'm not entirely sure I have them in right order. I probably don't actually. But you need to have your 6 rights. You need to have the right patient. You can't be giving the medication to the wrong patient. You have to have the right medication. So you can have the right patient and have the wrong med. So you have to make sure you have the right medication. You need to have the right dose, the right time, the right route, meaning are we giving it PO? Are we giving it transdermally? Are we giving it sublingually? Are we giving it buccally? Are we giving it IV, IV push, IV piggyback? We need to know the route. And then last but not least, you need to have the right documentation. You need to make sure that you documented it appropriately, that you gave it to the right patient, the right med, the right dose, the right time, and the right route. So you need to document that properly. It's important to know your 6 rights. All right, conversions. You got to start somewhere. So again, these are very, very basic. These are very baseline minimum. I think I actually have this backwards. A kilo is 2.2 pounds. So a kilogram is 2.2 pounds. 2.2 pounds is 1 kilogram. I have that backwards. I needed to fix that. No, I have that right. 1 pound is 2.2 kilograms. Yes, I have that right. 1 pound is 2.2 kilograms. I almost screwed myself up with that one. Okay. 1 pound is 16 ounces. 1 fluid ounce, that's fluid ounce, that's not actual like weight ounce. 1 fluid ounce, is 30 milliliters. 1 teaspoon is 5 milliliters. 1 tablespoon is 15 milliliters. A cup is equal to 8 ounces or equal to 240 milliliters at 30 mLs per ounce. And these last two I know are kind of like, well, no duh, we do this every day. 1 hour is 60 minutes and 1 day is 24 hours. That's really important when you're calculating how many doses are given in X amount of days and how many hours per dose and blah, 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 blah. So I'll explain more when we get there. So let me move forward. Okay. I know I spoke about this in the first installment with math for the T's. King Henry died by drinking chocolate milk. I honestly have no idea why the US has not transferred over to the metric system, because the metric system is made wonderfully, seamlessly, smoothly. Dang you, US, get your crap together. Anyway, it doesn't matter if you're working with liters, grams, meters, anything. When you're using these kind of foundational things and you need to convert them, you just move the decimal. So if we're converting from kilograms to centigrams or milligrams or whatever, you just move the decimal down. If you have 3 kilograms that is 3 million milligrams, because you just move that decimal down those many points. It may actually be 3,000. Well, let me find my little pointer pen here. Oh my gosh, look at that. That is the coolest thing. I'm recording this with PowerPoint, so hopefully this actually works like I want it to. Okay, so if you have 3 kilograms, you just move it down. So that's 30, 300, 3,000, 30, 300, 3 mil. Right? Or did I do that wrong? Anyway, going back to it, you just move the decimal up or down. When you have to use the metric system, it's your new best friend. It literally makes life so much easier. Anyway, moving on. Qualms with the United States aside. So again, we're going to kind of do that whole thing. If I have, 4.5932489 kilograms, but I need to know how many milligrams that is, we're going to move it down. Henry died by, so this would be how many grams? There's 4,593 grams in 4.5 kilograms. Does that make sense? So if we keep going down, died drinking chocolate milk. So if we have 4.5932489 kilograms, that translates to 3,593,248.9 milligrams. So it doesn't matter if it's liters, it doesn't matter if it's meters. You just move that decimal up or down. So this would be, again, kilograms, hectograms, I think it's decagrams, don't remember, but this would be your base of like grams, meters, liters, whatever, decigrams, centigrams, milligrams, so on and so forth. And this would probably be this would be micrograms. Anyway, moving on. All right, the right dosage makes all the difference. Yeah. Okay. With your going into your nursing program, whether you are doing pre-nursing, you're going into your program. If you're doing pre-nursing, you're probably doing some algebra, some college algebra, intermediate algebra, and you're probably able to use these wonderful graphing calculators, which make life a wonderful place, especially if you're planning on going into a bachelor's program and you have to take the like horrendously awful statistics. Oh my gosh, statistics will make you want to beat your head inside out. It's terrible. It's terrible, you guys. It's so bad. If you're going to take statistics, take it by itself for the love of God and get a really good tutor. I had a really good tutor and she saved me. And I had this. It saved me. Now, in the nursing program, this goes bye-bye. You cannot use these on any nursing exams, at least not at Yavapai College, and I believe not with ASU. You cannot use these in your exams. You are given a basic, bare bones, minimum, old school calculator, just like the one you see in this slide, which is actually very funny. With the whole COVID movement to everything online and with our exams being proctored, we are not allowed to use these because testing center can't, there's no testing center, you're just being proctored. So if I'm using my calculator, I can save and store things on here that, I don't even know how to do that, by the way, but apparently you're totally can. This whole interface is you're able to upload and store files and equations on here. That would be cheating in nursing school because you need to be able to start from the actual bottom and work your way up. These basic calculators, exactly like one you see on the slide, are the ones that you will either be issued by the testing center or provided to you either as like a pop-up with your proctored exams. Anyway, that calculator that's on the screen is the exact calculator that I use for my It's a cartoon version, obviously. I don't really use cartoon calculators, but that's the exact same one that I use in my exams, and it's great. It's wonderful. I'll post a link to that calculator in Amazon in the comments below. So, but it kind of sucks because it's out with the new and in with the old. So that may be something you kind of have to adjust to moving into a nursing program. Just a heads up. I wasn't ready for it. I hope you guys will be too. Okay, practice conversions. So I'm going to try to use this as a pointer. It may not work very well, but we're going to try. So we'll start with this first question, 275 pounds to kilograms. So what we have to do, oh gosh, I'm going to try to use my thing, my stylus, but we'll see if it works. Okay. Oh, that's bad. That's even worse than my regular handwriting, guys. This may take longer than I want it to. I'm sorry. You guys are great. Thank you for being patient. 275. And then, so if 1 pound is equal to 2.2 kilograms, what do we have to do? Well, we have to divide. Point. Oh gosh, 2.2. So I don't have my handy dandy trusty calculator, my old one. So I have my new, old one. I don't have my new one. 275 divided by 2.2. My children must have made off with it. I don't know where it went. So how we find pounds to kilos is you divide by 2.2. That equals 125. Oh gosh, that's actually with my fingers, guys. I did that with my finger. Oh geez. So 125. So that's how you find pounds to kilos. And as you can see over here, we've got 220 kilos to pounds. So let's just kind of fast forward and show how to do it backwards. 220. Oh my gosh, I'm so sorry, guys. That looks like I'm starting to spell ZZ Top. 220 times. I wish there was a way I could type it out, but I can't. This is actually the second time I've recorded this, and I tried to do it with Zoom and just record it with my tablet, and it didn't work. 220 times 2.2. So that's a big person. 220 times 2.2. You get.
You want me to turn it off?
480. Ooh, golly. 484. Oh my gosh, that's so bad. Okay, so you get 484. 220 by 2.2 equals 484. So let me clear this out.
You want me to turn it off?
Oh my gosh, don't you love commentary when you're trying to do recordings? It's my favorite. It's the best ever. Said no one ever. Here we go. 4 cups to mLs. So, do we remember how many ounces are in a cup? 4 cups. Okay, well, there are 8 ounces in a cup. Sorry, you guys, I'm trying so hard. This is really rough, so my face is showing all my anxiety. I'm sorry. 4 times 8 times, okay, remember how many mLs are in a cup? Oh my gosh, that's a terrible zero. We're gonna roll with it though. 4 times 8 times 30 equals 9, oh golly, 60. This is worse than my handwriting, you guys. My finger is just poopy pinata. Okay, 960, because you have 4 cups times 8 ounces per cup times 30 mLs per ounce. So you get 960. 4 cups equals 960. And this equation is really important when you're specifically calculating intake and output, when you have somebody who's on maybe some fluid restrictions. So you have to know how much they've drank per day. And then you have to be able to calculate how much output they've had per day, and then see if there's a deficit. So if maybe they're peeing out more than they're drinking, or if there's an excess. So they're holding on to more fluid than they're drinking, or than they're letting out. Does that make sense? So it's really important to be able to calculate the cups to ml, because you can ask the patient, like, okay, well, how many cups of orange juice did you have for breakfast? Like, about how many ounces did you drink? How big is your water bottle? How many water bottles have you drank? Things like that. You can ask the patient and get to know them. Okay, this one's super easy. This one is like really, really, really ridiculously easy. We're just gonna blow right through it, because King Henry died by drinking what? Chocolate milk. So, oh my gosh, that's a huge 0. We're just gonna roll with it. Okay, so we have 1,000 mLs. So we have chocolate milk. Chocolate drinking by 1 liter in 1,000 mLs. Simple. Super duper 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 simple. Okay, moving on. 2 teaspoons, not teaspoons, teaspoons to ml. So we have to figure out how many mLs are in a teaspoon. So we've got 2 teaspoons times, how many mLs are in a teaspoon, guys? Do you remember? Do you remember? And this is really important because, so like let's say your patient is being discharged and being sent home with a liquid oral solution, and the only thing that they have to measure this out with is some measuring spoons. But it says that, you know, it's 5 milligrams per milliliter, and so they have to know, you have to teach them how many mLs to give per dose. And then you have to teach them, okay, like I know that this says, you know, 5 milligrams per ml, but I want you to remember that it's, you know, so like let's say it's a milligram per ml. Well, we know that there's 5 milliliters in a teaspoon, and let's say that their dose is 10, right? So we would teach them to give themselves 2 teaspoons of the medication in order for them to get their 10 milligrams of medication. So that's really important, specifically with discharging patients at home, because they don't have access to the medical devices in the hospital. They don't have access to those specific things. So you have to be able to teach them that. So if their medication was, you know, 1 milligram per ml, again, and they needed to give themselves 10 milligrams, you can teach them to give them 2 teaspoons. Okay. Moving on. Okay. 90 mLs to ounces. So we've got 90. My little camera thing's in the corner, so I don't know if you can even see this. 90 to ounces. Well, how many mLs are in an ounce? Okay. 30. That's how we're going to figure this out. Because if we know that there's 30 mLs in an ounce, we would just divide the 90 by the 30. So 90 by 30, 3, we know that 90 mLs, or 90 mLs is equal to 3 ounces. Oh golly, that's tiny. I don't know, like maybe my little camera thing isn't in the bottom corner like I see mine as, but whatever. Anyway, anywho, moving on. All right, now on to the nitty gritty. Dosage calcs. Don't worry, don't freak out. Yes, you can do this. These are the 1 questions on your math exam that you can actually check. Like, I cannot tell you how many other people are in my cohort right now that we just look at each other and we go, I love dosage calc questions. Those are the ones I know I'm going to get right. It's It's really kind of sad, but it's true. Like, we all look at each other and go, yeah, I know I'm going to get dosage calc questions right. I know that for sure. All right, so again, because I don't like to take life too seriously, dear algebra, please stop asking us to find your x. She's not coming back. Don't ask why. I love that she is the x and she left. Like, what happened there? Why isn't it a he? I don't know. Who knows? Practice questions. Moving on. Okay, so you have 90 milligrams of aspirin. The available dosage strength is a scored 60 milligram tablet. What amount will you administer? Okay, so with dosage calc questions, you always have desired over have. So we look at this question, what is desired? What do we want to give this patient? Well, the order is for 90s. We have 90. Desired, what do we have? Well, we have a 60 milligram tablet. Again, I'm sorry guys for the handwriting. So how many tablets will we give? Well, we gotta divide 90 by 60. Whoops. Don't know why I did that. Okay, 90 by 60 equals 1.5. So if they're a scored tablet, we can give a half a tablet. 1.5 is your answer. Okay, so here we go. Normal saline, 1 liter IV over 8 hours. How many mLs per hour should you set the pump to? This one's kind of a trick question because there's a conversion in there. You don't quite see it because it's not blatantly obvious in your face, but here's our 1 liter IV over 8 hours, but we have to convert it to mLs. Well, you guys are geniuses and you already know how to do that because we've talked about this before. We know that that is, oops, golly, 1,000 mLs. Now, it's desired over have. We have to set a pump rate. So the desired is 1,000 over, what do we have? 8 hours, right? So you can manually set the pump to that. And how you do that is you just open the IV wide open and then you apply it to the pump. And the pump will administer how many, it gives the appropriate dose as long as you do it correctly. So we have 1,000 mLs over 8 hours. That equals, you will set that pump to 125. Oh my gosh, you guys, I'm so sorry. I need to get one of those pads that you can actually use a stylus on. 125 ml per hour. Give me just a second really quickly. Sorry, minor break there to tell children to shut their bleeding holes. Okay, moving on. Okay, so this next one, if we have 200 micrograms of digoxin, but we have 0.125 milligrams and 10 mLs, how many mL should the patient receive? So here's another conversion. If we have, oh golly, that was a lot bigger than I wanted it to be. Let me try this again. Oh my gosh, I need one of those pads, you guys, that has the stylus things that I can just write. No, but I know, but I can't use a stylus on my thing. My other child is trying to show me this. I have a stylus, dude. It just won't work on a tiny little, I can't even. On a white girl scale to OMG, and I can't even. I can't even. Okay, 250 micrograms over 0.125. Okay, well, we have to get micrograms to milligrams or milligrams to micrograms. I'm going to go milligrams to micrograms and just move that decimal on down. 1, 2, 3. So that makes 125. So we have desired over have 250 divided by 125 equals, damn it, 250 divided by 125, it's been a day, guys, 2. So that equals 2. And then what we have to do from that point is we have to multiply. because if the 125 is per 10 mLs, but we need to give 2 of that dose, 2 times 10. So the patient will receive 20, oh golly, I'm so sorry you guys, 20 milliliters. That's our answer. Oh, I don't know why I tried to circle it, that just made it worse. Anyway, that's our answer, 20 mLs. Okay, here we go. Now this one's kind of interesting because it throws you information that totally isn't relevant to the question. It is simply put in there to trip you up and make you go, gotta figure it out. I'll walk you through it because you need to focus on the desired over have and what they're asking. And I'll show you how to get rid of the crap out of the questions like these. So the order is for furosemide, 60 milligrams oral solution by mouth now. So desired over have. Desired, we have 60, oh gosh, 60 milligrams, okay? Available is a 60 ml bottle that contains 20 milligrams per 2.5 ml. How many mLs will you give? So yeah, that's great that the bottle has 60 milliliters. Great, whoop-de-doo. I don't care about that. I do not care about that. The bottle, how much is in that bottle, doesn't even apply. Get rid of that. It has no business at all in our equation. Just get rid of it. Like literally take it out of your brain, just go, okay? So desired over have. We have 60 milligrams of oral solution over 20 milligrams. Desired over have. So 60 divided by 20 equals 3. You do it the same thing. 3 times 2.5 equals 7.5. So we know that we give 7.5 mLs. Now, guys, with these questions like this, you will get questions that will also incorporate milligrams per kilograms. So like it'll be an antibiotic per se, because we're not going to give the same dose of antibiotic to a 60-pound pediatric patient rather than a 260-pound adult patient. It can be the same medication, just completely different doses. So you, again, have to convert the pounds to kilograms, and then you have to multiply the milligrams to kilograms. So the conversion and understanding those things and having that information quick on tap in your head is really important. If you need to rewind and go back over those just very, again, rudimentary conversions, please do. Moving on. Okay, here we go. This is kind of one of those weird ones like I was talking about. So sulfamethoxazole, trimethoprim, 6 milligrams per, oh my gosh, it's a freaking typo. I didn't fix it. Just, that's supposed to be a G, guys. Sorry. Look, I fixed it, kind of. Oh, it just looks like an 8. It looks like it's a retarded 8. Okay, 6 milligrams per kilograms IV every 12 hours. The patient weighs 220 pounds. What's available is sulfamethoxazole, trimethoprim, 500 milligrams and 5 mLs. How many mLs will be administered in a 24-hour period, and how many mLs per dose? So this is a multifaceted question. So let's start with let's start with the dose, right? So patient weighs 220. Well, it's kilogram, so we have to divide that 2.2. 220 divided by 2.2 equals 100. Well, that's easy. 100 kilos. Oh, that's actually a really nice 0. Oh, nice. Next to whatever. I can't even right now, you guys. It's been a day. Needless to say. Okay, 100 kilograms. So then we take 6 milligrams and we multiply that by our 100 kilograms. Because if we have to give 6 milligrams per kilogram, and we know this patient is 100 kilograms, we have to multiply that. Oh my gosh, you guys, I'm so sorry. This is really bad. I'm trying my hardest. Literally, like my poor little finger is like shaking on my pad. Probably, you can probably see it in my computer. Okay, so that equals 600 milligrams, right? 600. Cool. Now, what we have is 500 milligrams per ml. Well, if we want to simplify that even further, we can see right here that there's a common denominator. There's 5. So if we can basically eradicate that, we know that it's 100 milligrams per ml. So if we need 600 milligrams, we know we need 6 mLs per dose. Right? Because if it's 500 milligrams, but our dose is 600 milligrams, oh my gosh, that circle was terrible. We know that it's 100 milligrams per 1 ml because we can eradicate that common denominator. We can just kind of clear that out. And then, again, 600, 6 mLs. So how many mLs will be administered in a 24-hour period? So if we know that 6 milligrams per kilogram is IV every 12 hours, we need to double this. This patient's going to get 12 mLs per day. Got it? Anybody lost? Anybody lost? Hopefully not. Let's move on. All right. I promised you that I would touch base, just like very, very briefly touch with drip rate. Don't worry, you're not out of your drip in mind. It's really simple. Again, that whole desired over have, there's a whole system. Some people use what's called dimensional analysis. And dimensional analysis is great for when you have to figure out the drip rate on top of milligrams per kilograms per hour. And then you have to factor in your tubing, your drip rate with your tubing. So dimensional analysis is great for that. I really struggle with dimensional analysis. I get really lost in it. So if dimensional analysis works for you, I would advise you to literally just stop watching this video and just keep doing what you're doing. But if you struggle with dimensional analysis, I'm going to try to simplify it for you a little bit because this is what I do and this is what helps me. It doesn't help everybody else. This is just what helps me. So you got to figure out the amount. Again, that whole desired over have. The amount, we have to look for the time. How long do we give the dose for? And we have to look at the rate. How fast do we give it? So again, I'm going to walk you through this. So the amount of medication over time, and this is the tubing. This is the tubing right here. This is where this comes from. And again, I'll explain this all in just a minute. But basically how I break it down is this equation right here. I do the amount times the tubing over the time. Because that just gives me my rate super fast. Gives me my rate super fast and I can check it. So let's move on. Okay, we've got lactated ringers, 1,000 ml IV over 8 hours. Our drip factor is 10 drops per ml. How many drops per minute should this infuse? So I'm going to set this up and I'll show you how I set it up. We've got 1,000 mLs over 8 hours. Well, here, I'm going to stop right there. There's a reason why I gave you the conversion of how many minutes are in an hour. Because if we need to know how many drops per minute, we cannot do this equation in hours. So before I even write this down, I caught myself. I want to know how many minutes are in 8 hours. So we take 8, multiply it by 60. We've got 480 minutes. So I need to give 1,000 mLs over 480 minutes. It's still 8 hours, right? but I need to break this down to minutes to figure out my drip rate. Again, guys, I am so sorry for my handwriting. I'll see if I can splurge for one of those stylus pads. Drip factor is 10 drops per ml. So we already know that it's 1 ml, right? So that's why I don't even include this in the equation. I just do times 10 GTT, because GTT also stands for drops. So how I set this up is I set it up with 1,000, just like I showed you in that previous slide. So sorry for the terrible handwriting. Times 10. Oh my gosh, I'm sorry, you guys. Divided by 4. I'm going to try to do it that way now, so I don't have to pick up my finger. 480. So 1,000 times 10 divided by 480. 20.8333333333333. So I've seen pumps in an ICU that you can give a point factor, but for the most part, at least this is what I've been taught repeatedly with Yavapai College's nursing program. When you're dealing with drops per minute, you always round to the whole drop, because you can't. There are some pumps you can do a partial drop, like specifically pediatric pumps, or ICU pumps when you're dealing with like really serious medications that the dose needs to be that exact. But for the most part, the pump can't give a partial drop. So we're thinking about like a heparin drip. If we're thinking about like a morphine drip, you have to think about the fact you can't give a whole drop. So you always round up. So if that equals, oh golly, I'm so sorry, you guys, 20.8, I'm just going to stick with the way that I do 8, 3, and it carries on 333333333. Try to fix that too. Again, you just round up. You would set this pump to infuse, 21 drops per minute. GTT over. Does that make sense? And so with dimensional analysis, it will have you line it up with 1,000 over 8 times 1 over 60 times. I think dimensional analysis sometimes overcomplicates things. At least in my brain, it does. So this is the way that I do it. I literally set it up with I cross multiply and I divide it by my minutes. I have to figure out what my dose is, and I cross multiply and I divide it by my minutes. So it doesn't matter if I have to give 1,000 ml or 1,000 mLs with a weight of a patient for this and that, but the point is that I put that desired over half and I multiply it, I cross multiply with my desired times my drop rate over my minutes. That's the important part that I want you to take away with drip factor, it's the dose over the minutes. You'll get a totally wonky answer if you don't convert those hours to minutes, and then you times it by your drip rate. So I've got, I don't know how many more I have. So here's another one. We have 50 ml over 30 minutes. My drip factor is 15 drops per ml. I don't know what happened with that 5 right there. That's kind of wonky, but we'll just deal with it. So, what drip rate should this infusion run? 50 times 15 divided by 30. We need to give 25 drops per minute. I hope this kind of makes sense how I simplify it. Okay. You literally cross multiply your amount times your drops, and then you divide it by your minutes, and then you get your answer. Okay? I think I've got one more. Never mind, I don't have one more. Just kidding. So, a lot of these problems were brought to you by the letter F. Okay, not really. But there's tons of dosage calculation worksheets out there. I do them all the time. My favorite is nursing.com. I know that I've mentioned them a lot in a couple of my other videos. I am not affiliated with them. I just love what they do. I love what they do. I love their entire core value system. I love even their customer service is just like spot the frick on. I post on their Facebook page and Tammy Hawes responds literally within hours. She is amazing. Nursing.com. I cannot scream from the rooftops how much I love nursing.com. And nurselabs.com is great. They actually have NCLEX style nursing questions, so they're a little bit more difficult dosage calculation questions, but they're ones that you will see on the NCLEX. So if you are a nursing student and you are just looking for more resources for dosage calc, nurselabs.com. That's your friend. I'll add the link below to the comments, but again, nursing.com, nurselabs, there's tons of dosage calc worksheets on the web that you can use, and I love them. Dosage calc questions literally make my heart sing. Okay, and just to kind of like recap, let's rein it back in. You guys did a great job, so treat yourself. I want you, when you look at the question, I want you to focus on the numbers that are pertinent. Again, like sometimes they'll throw things in there literally to just throw you off. It has nothing to do with the question. Desired over have. You need to focus on that. What is the dose that I need to give, and what is the amount that I have to give it in? Desired over have. Number 2, desired over have. And what's really great about dosage calc questions is you can work the question backwards and check yourself. So check again and recheck, check again and recheck. Because that kind of mentality, specifically in the nursing field, will serve you well. Medication errors are bound to happen. There is no nurse in this world that has not made a medication error. I guarantee you, a nurse that has not made a medication error has never seen a patient. We always kind of like plan for the worst, but we hope for the best, right? We never want to go into work, saying that I'm gonna make a med error, so I might as well do it now. Like, no. You never want to make a medication error, but the fact of the matter is that it's going to happen. It's just, is it a sentinel event? What's the severity of it? Did the patient have a poor response? Did you document it? For the love of God, be accountable and document the damn thing. Like, yeah, you made a mistake. Own it and learn from it. But anyway, sorry for the soapbox. Check again, recheck, avoid the mistake if you can. Thank you guys so much for listening and for following along. This adorable template of, I've been doing PowerPoints like crazy for my ASU classes. This adorable template was brought to you by slidesgo.com. If you sign up for just, again, I'm not affiliated, I just love them. If you sign up for just a basic account, it's free they basically don't even send you, they don't even send me emails, really. Like, they're great. You just download, I think you're allowed to download 10 templates a month with your account. I think it's 10 templates a month. Anyway, I feel like I do PowerPoint presentations every other week for ASU, and it's fun. Like, they have a ton of really cute, adorable templates, and I'm glad I got to share this one with you guys today. If you have any questions or concerns, leave comments below. Like this video, share it. If it helped, again, let me know what I can do to help and how I can help you guys further. But thanks for joining me, and I hope you guys have a great day.